Picture a creature the size of a rabbit hopping through ancient African forests 60 million years ago. This small, unassuming mammal possessed something extraordinary: enlarged front teeth that would one day become ivory tusks. Fast forward through time, and its descendants tower over the landscape as 12-ton giants. This is the story of elephants, a dynasty that has dominated Earth for longer than almost any other mammalian lineage. From rabbit-sized ancestors to aquatic plant eaters, from shovel-tusked behemoths to woolly titans of the Ice Age, the elephant family tree sprawls across continents and epochs. Their evolution spans 60 million years of triumph, adaptation, and survival against impossible odds. This is the greatest transformation story in mammalian history: the rise of the Proboscideans. Africa's hidden origins. The story begins in Morocco 60 million years ago, when dinosaurs are nothing but fossils. The world is recovering from catastrophic asteroid impact, and mammals are seizing their opportunity. In North Africa's lush forests, a small creature about the size of a rabbit moves cautiously. This is Eritherium, the earliest known ancestor of modern elephants, and it looks absolutely nothing like them. Eritherium possesses features that seem almost contradictory when we consider what its descendants will become. It has canine teeth, a characteristic that will vanish completely in later Proboscideans over millions of years. Yet hidden within its skull are hints of the future waiting to unfold. Its first incisor tooth is enlarged compared to other mammals, laying the foundation for tusks. The placement of its eyes, positioned higher on the skull than typical mammals, foreshadows adaptations yet to come. This tiny animal represents the humble beginning of one of evolution's most spectacular success stories. Eritherium belongs to Afrotheria, a group of mammals that evolved in isolation when Africa drifted as an island continent. This geographical separation created a unique evolutionary laboratory, allowing African mammals to develop in radically different directions. Among these experimental lineages, Proboscideans will become the most diverse and successful group of all. 10 million years pass, and the evolutionary torch passes to Phosphitherium, a dog-sized creature appearing in Morocco. This animal shows clear progression toward the elephant body plan that will eventually emerge completely. Its molars display cross-crested patterns perfect for processing varied plant material from multiple sources. The snout lengthens noticeably, though it still lacks anything resembling a true elephant trunk. Each generation builds upon the previous, adding small modifications that accumulate into transformative change. By 37 million years ago, Proboscideans have produced something truly unusual in Moeritherium, discovered in ancient Egyptian deposits. This barrel-shaped creature lived a semi-aquatic lifestyle in rivers and swamps that covered North Africa. Short legs propelled its bulky body through shallow water, while a lengthened snout grasped aquatic vegetation. Small tusks protruded from its mouth, tools for digging up roots from riverbeds and lake beds. Moeritherium represents a fascinating experiment, a proto-elephant adapted for life in water rather than on land. The Great Radiation. Around 35 million years ago, the Proboscidean family tree explodes into a dazzling array of forms. Two main branches diverge, each pursuing different evolutionary strategies that will define their descendants' fates. One branch leads directly toward modern elephants through a winding path spanning millions of years. The other branch, called Plesiolephaniforms, creates parallel lineages that will thrive until the Ice Ages. The earliest Plesiolephaniforms belong to a family called Nemedotheridae, including animals with increasingly specialized features. Mammotherium develops a distinctive scoop-shaped lower jaw, perfect for scooping up aquatic plants from muddy bottoms. Its stocky limbs support a body built for stability rather than speed in watery environments. These early experiments in Proboscidean diversity show evolution testing multiple solutions to survival challenges simultaneously. The late Eocene brings forth Eritherium, a family of increasingly massive animals pushing size boundaries upward. Eritherium and Moeritherium lumbered through North African landscapes, some individuals reaching 2 tons in weight. They stood 2 meters tall at the shoulder, impressive by any standard for their era. These animals possessed cross-crested molars for grinding tough vegetation and trunks of varying lengths. The Proboscidean body plan is crystallizing into something recognizable, though still distinctly different from modern elephants. Then comes one of evolution's most bizarre creations, the Deinotheriums, including the spectacular Deinotherium itself. These animals grow to an astounding 12 tons, exceeding even modern African elephants in sheer size. But their most striking feature is their tusks, which point downward from the lower jaw. These peculiar adaptations serve as digging tools for unearthing roots, tubers, and underground plant storage organs. Deinotheriums spread from Africa into Europe and Asia, becoming some of the most successful proboscideans ever. The true elephant lineage, Elephanthiforms, begins its own journey during this time of explosive diversification. Early genera, like Paleomastodon and Phiomia, retained semi-aquatic habits inherited from their ancestors' lifestyles. They possess shovel-shaped lower tusks perfect for scooping vegetation from riverbeds and shallow lake bottoms. Gradually, generation by generation, these animals spend more time on land and less in water. The transition from aquatic to terrestrial life is underway, driven by changing climates and new opportunities. Mastodons and Gomphotheres. From the Elephanthiforms branch emerges one of the most successful proboscidean families, the Mastodons. These animals, classified as Mammutidae, develop a body plan perfectly adapted for forest environments. Unlike their relatives who prefer open grasslands, Mastodons thrive in dense woodlands where they browse leaves. Their teeth feature blunt, cone-shaped cusps ideal for crushing woody vegetation and tough plant material. The American mastodon, Mammoth americanum, represents the pinnacle of this lineage's evolutionary journey to success. These animals spread across North America, filling ecological niches from coast to coast and border to border. Their flatter body shape distinguishes them from the more dome-headed elephants and mammoths to come. They possess shorter legs relative to body size, an adaptation for navigating thick forest undergrowth. For millions of years, mastodons reign as one of North America's most successful large mammals. Meanwhile, another spectacular group evolves. The Gomphotheres, family Gomphotheriidae, with their incredible diversity of forms. These animals develop an astonishing variety of tusk configurations and body shapes for different environments. Some Gomphotheres retain 4 tusks, 2 upper and 2 lower, creating a formidable dental arsenal. Others lose their lower tusks entirely, converging on the modern elephant body plan independently. This family spreads across continents, eventually becoming the only proboscideans to reach South America successfully. The Megalodonidae family produces some of the strangest proboscideans ever to walk the earth. Platybelodon, the shovel-tusker, develops enormously broad, flattened lower tusks resembling a bulldozer-blade. These bizarre structures serve as bark scrapers, allowing the animal to strip nutritious cambium from trees. Amoebelodon possesses similar adaptations, though its shovel is slightly narrower and more pointed forward. These animals represent evolution pushing the proboscidean body plan to its absolute functional limits. Gomphotheres achieve remarkable success, adapting to wetlands, marshes, riversides, and even relatively dry grasslands. Their ecological flexibility allows them to occupy diverse habitats that other proboscideans cannot exploit effectively. Some species develop incredibly long tusks that curve gracefully upward and outward from their skulls. Others keep their tusks relatively short and straight, more practical tools for everyday feeding. This radiation demonstrates the evolutionary potential hidden within the proboscidean body plan from the very beginning. The rise of true elephants. Around 7 million years ago, the Elephantoidea superfamily emerges, bringing forth the animals we immediately recognize today. These are the true elephants and their closest relatives, possessing shortened faces and dramatically enlarged skulls. Their tusks grow to enormous sizes, sometimes reaching lengths exceeding 12 feet in exceptional specimens. The skull develops air-filled chambers that lighten the bone while maintaining strength and structural integrity. Multiple families experiment with this new body plan, each adding their own modifications and specializations. The Anancidae family produces animals with spectacularly long, straight tusks pointing almost horizontally forward. Stegodontidae develops even more extreme tusks, some individuals possessing both upper and lower ivory projections. These animals spread across Asia, adapting to tropical and subtropical environments from India to Indonesia. They represent the diversity still present in elephant evolution even as modern forms begin appearing. Then, approximately 5 million years ago in Africa, the genus Mammoths appears. The mammoths have arrived. These animals will become the most famous extinct Proboscideans, capturing human imagination like no other. Early mammoths are relatively small, adapted to Africa's warm savannas and grasslands like their ancestors. But as they spread northward into Eurasia, they encounter entirely new environmental challenges never faced before. The woolly mammoth, Mammoths primigenius, evolves as a direct response to Ice Age conditions across Eurasia. Thick, oily fur covers their bodies, providing insulation against temperatures dropping far below freezing regularly. Small ears reduce surface area exposed to cold, preventing heat loss and potential frostbite damage. A distinctive shoulder hump stores fat reserves for surviving long, harsh winters when food becomes scarce. These adaptations transform mammoths into perfect Ice Age specialists, thriving where few other animals can. In North America, a different mammoth species evolves. The Columbian mammoth, Mammoths columbi, adapted to warmer climates. These giants grow even larger than their woolly cousins, standing up to 14 feet tall. They lack the thick fur coats of woolly mammoths, instead sporting short hair like modern elephants. Columbian mammoths dominate the continent's grasslands, living alongside mastodons in an ecosystem richer than anything today. Two distinct mammoth lineages show how the same basic body plan adapts to radically different environments. Some mammoth populations undergo dramatic size reduction due to island isolation effects over many generations. Dwarf mammoths evolve on Mediterranean islands, California's Channel Islands, and even Wrangel Island off Siberia. The Wrangel Island population survives until an astounding 1650 BC, when Egypt's pyramids already stand ancient. These tiny mammoths, standing barely 6 feet tall, represent evolution's flexibility even in a highly specialized lineage. The survivors. While mammoths captivate our imagination, another lineage quietly evolves toward the present day, the Asian elephant. Elephas maximus appears in the fossil record during the Pliocene, around 5 million years ago. This species shares a closer evolutionary relationship with mammoths than with African elephants, a surprising fact. Asian elephants and mammoths both prefer grazing on grasses, while African elephants mix grazing with browsing. Modern genetic analysis reveals that African elephants actually represent two distinct species, not one as believed. The African forest elephant and African savanna elephant diverged millions of years ago evolutionarily. They occupied different habitats, possessed different body proportions, and rarely interbreed in natural conditions. This discovery doubles our count of living elephant species from 2 to 3 overnight. Today, these 3 species represent the last survivors of a family that once numbered dozens. From rabbit-sized ancestors to 12-ton giants, from 4-tusked oddities to aquatic plant eaters, Proboscideans dominated every continent. They adapted to forests, grasslands, deserts, tundra, and tropical islands with remarkable evolutionary flexibility. Their success story spans 60 million years of continuous innovation, survival, and adaptation to changing worlds. Yet all three living elephant species face existential threats from human activities and habitat destruction. Poaching for ivory has decimated populations across Africa and Asia, reducing once vast herds dramatically. The African forest elephant, rarest of all, teeters on the brink of extinction classification. Habitat loss fragments remaining populations, making breeding and genetic diversity increasingly difficult to maintain. The survivors of evolution's longest success story now depend entirely on human choices for survival. 60 million years of evolution brought us from a rabbit-sized creature to Earth's most magnificent giants. The elephant family tree sprawls across time and space, filled with bizarre experiments and spectacular successes. Today, only 3 species remain from this once mighty dynasty, all threatened by extinction. If we lose them, we lose living connections to an evolutionary epic spanning the entire age of mammals. The question isn't whether elephants deserve saving, it's whether we deserve them.